Alright class, today we are doing an airplane experiment that involves scientific method. This lab should help us get an idea how to follow through the process of the scientific method. The objective is to make flying airplanes by following scientific method, work in groups of 2 or 3, so we're going to have to get into groups today. I'll allow you to choose your own groups. Understand the terms and how to use the scientific method. The problem, design an airplane that can fly farther than Mr. Asila's design. I will give you my design that you will make, and then you will fly it. Materials you'll be given: paper and scissors, crayons, pencil, markers, and my airplane design. The procedure: students will all make one airplane that follows Mr. Asila's design. We are going to actually do this right now to make sure you can design my plane by following my steps. Step 1: get an 8.5 by 11-inch piece of paper from the middle of the room. Everybody in the class should pick up one sheet of paper, white paper. Step 2: you're going to crease the paper in half, hot dog style. So just fold it in half with the crease right here, so it's hot dog style. Step 3: now you're going to fold the corner down on one side of the paper. So here, you just take the corner and fold it down so you have a crease right here. Step 4: fold the other corner down. So now you have a crease here. So here's the bottom of your paper where there's an opening. This is the crease, and you crease both sides down on your airplane. Step 5: fold the folded flap down so angled edge meets the bottom edge. What you're going to do is you're going to take your original angle that looked like this and simply grab it right here from this point and fold it down to here. So now your new crease is right here. So your crease should go from the tip of the plane all the way to the back of the plane. Here's your bottom of your plane. The original bottom is right here. So now you just made yourself a triangle with your new fold. Step 6, you're going to repeat step 5 with the other wing. Then fold each wing one more time just like you did in step 5. Your plane is now complete and ready to be decorated. So if you go back to step 5, what you did here, you have to do to the other side of the plane. Then you're going to take this creased edge right here for step 7 and fold it again over until it meets the bottom perfectly. And your plane then looks like this picture. There is another view of it. And after I decorated my plane, it looks like we call it the ace flyer right here. So now everybody should have a plane that is after my design. Now the reason you're making my design is because in the scientific method, when we come and do an experiment, you need to test one variable at a time. So you are going to build my plane, so it's the same builder for each of the planes, as well as fly it and collect data. So we'll go back to the procedure. Now that everybody has my plane design, the students will record 5 distances that the plane flew in a chart under data and experiments. Distances will be marked in the hallway. So what's going to happen is we're going to all go into the hallway, and you're going to fly my designed plane, the one I designed that you built, right here. Trial 1, 2, 3, 4, and 5. Then you're going to find the average by adding those 5 trials up and dividing by 5. Now you'll know on average how far my plane will go. Step 3, the students will then design their own plane. This is where you have to go through and design a plane based on your hypothesis. You can do research first. You should always do background research to design a plane that may fly better than mine. You collected my data, you know how far it's going to fly, you know what it looks like. You're going to follow the scientific method in order to find out if your design will be better. How you do this is step 4, once a plane is designed, you're going to fly it, record the distances. You must find your averages and then compare the average distance. You record all the information on the following sheets where we will lead you through the scientific method. So here you get the scientific method, your question. Everybody's question will be, will my plane fly farther than Mr. Asila's? So that's a question you're asking and trying to answer. First thing you're going to do is come up with a hypothesis. An example of hypothesis is, if I increase the width of the wings, then my plane will fly farther than Mr. Asila's because wider wings add more surface area for the air to hit and hold in the air. Now when you do your hypothesis, you know that you can only change one variable. So here you're changing the width of the wings. You cannot change anything else. Otherwise you won't know if it's the width of the wings or the other variable to change. So only change the width of the wings or only change the length of the fuselage. Only change one variable. Here's where, before you come up with your hypothesis, is you want to do some research by going online, maybe building some different planes and test flying them before you come up with a hypothesis. Once you come up with a hypothesis, then you're going to come up with a procedure on how to build that plane. That procedure should be a step-by-step instructions so that I can take those instructions without you present and build your plane. I would advise you grabbing a blank piece of paper and drawing them up and writing them up, but you must also draw pictures and reference those pictures in each step, as I did. As you notice, I took pictures with my camera and then show you those pictures. You can take a picture with your iPad and then trace those pictures onto a piece of paper if you want, if you are having troubles drawing. Once your procedure is done, have me check it. I want to see if you have followed the procedure and did your hypothesis correctly. After that, I will allow you in the hall to test fly your plane. Once you come up with your procedure, at that point, your hypothesis and your procedure, at that point, you are not allowed to change your plane anymore. You must test it, because it does not matter if your hypothesis is incorrect or correct. We're trying to follow the scientific method and find answers. Come up with 2 safety rules, such as do not fly the plane when other students are in front of you, or make sure that the plane is always pointed away from people, or any 2 safety rules you think are necessary. Here's where, when you're out in the hallway, you're going to collect the data. That's it. Collect the data, find the average. Once you have all your data collected, at this point you are going to analyze and come up with conclusions, such as you can try answering the question, did the plane fly farther than Mr. Asila's? Explain in detail. You always want to reference your data. For example, the data shows that the average flight of my plane is 15 feet and the average flight of Mr. Asila's plane is 17 feet. Since Mr. Asila's plane went farther, the data does not support my hypothesis. And then in conclusion, you might say, talk about if the hypothesis is correct or not correct, but pretty much all you have to do is make a statement like this. Step 2, answer the question, what could have caused your data to go wrong? Just talk about what could cause your data to go wrong. Did it hit a locker? Was the plane wrinkled after the first flight? Or what could have caused it not to fly as far as mine, if it didn't fly as far as mine? You can also talk about why it might not have flown as far as you would have liked to, or why could your data be incorrect? Could there have been something else that has happened? Did somebody throw your plane incorrectly? Once this is done, you will hand in the lab and sit down quietly and wait for everybody else to finish.